AEG Power Solutions is dealing with a lot of international customers. We are making appointments with them, and we discuss their strategies, what their plans for going forward, and that's what we're doing. So go with them around the world. There are a couple of markets which are very interesting. I mean, we are very strong positioned in Eastern Europe, and where we really have a market-leading position. But also there are the emerging markets. So India, we have a factory in Bangalore in India, and doing very well. India is growing very fast, and that is one of the fast growth countries for solar in the world. We're looking, of course, at China. We're looking at Japan, where the growth is. Then we have South Africa, a factory in South Africa, very well positioned for around 3 projects there. And not to forget the United States. And the United States also very fast growing market, as you know. So we have a team, we have the products there, and that is also one of the promising countries for us. Solar is growing so fast in India. Of course, it's grid, on-grid, let's say solar, but also there are plenty of opportunities for off-grid solutions in India. And that's also where we're looking at right now. When I'm talking about off-grid, then I'm talking really about, let's say, countries in Africa, African countries, but also in Asia. There are opportunities, India, as I mentioned before. And last but not least, what we don't have to forget are the opportunities for what we call hybrid solutions. So where you combine solar with diesel generating. So that is very interesting for mines, of course. So for Germany, of course, let's first talk about Germany. It is clear that the decreases of the feed-in tariffs, let's say, makes that people are looking very much what the return on investment is. And okay, I mean, if the return on investment is not attractive enough, then you will see that the demand will basically drop, and that's what's happening in Germany, of course. Apart from the anti-dumping thing that has also had an influence on the execution of projects, of course. People are basically waiting right now and see what's going to happen. I actually expect that countries in high irradiation countries like Italy, like Spain, let's say on the more longer term, you will see that project starts to happen with grid parity. I expect actually, and also it has to do with legislation, of course, right? But I actually expect that is going to happen in the next 4 to 5 years. Let's not forget, if you really look at the history of solar, then you actually see that the estimations, the expectations that the industry had on the growth has always been outperformed. And actually, let's say the expectations is that by 2017, the global market will grow to some 60 gigawatts annual installations. And actually, there are already people that talk about that 10 years from then, so basically 2025, 2027, the annual installation rate will be between 150 to even 300 gigawatts, so worldwide. So I'm very optimistic about solar. In general, there are plenty of opportunities. We should not forget that the global demand for energy is going to increase substantially, and solar, as I said before, I mean, is really suitable to be rolled out there. And so, in general, I would say very optimistic.
The very simple thing is, solar is there when people do not need the energy. It's sun given, and typically energy supply is load driven. Yeah, so power plants deliver energy when you want to have it, and in solar and wind it's different. I mean, they deliver energy not necessarily when you need it. It's just when the wind is there or the sun is shining. So, and that causes problems because the grid has to manage. The task is that the production exactly matches the consumption, and that's not the case in solar or wind. And there you need technologies bridging that gap, absorbing this, and this is storage. Imagine you have a solar park delivering, let's say noontime, a high peak, yeah, so because the sun is shining and nobody consumes the energy. I mean, okay, you have the heater, so you cook some meal, but you know the demand is not as high as the production. Then you have this gap, and normally this gap or this difference causes problems in the grid, yeah. And either you have to transport it very far away to, let's say, hydro plants in order to store this in excess produced energy, or you locally sink this energy for a very short time, for minutes, hours, in a battery storage system. So, and then when the demand increases and the production is reduced, you release the energy back to the grid. That's the idea. It's a demand basically of the utility providers. You know, they got no problems. You know, when solar is fed in, the voltage increases, the frequency increases, and there are methods in order to influence the solar feed in. You know, so our inverters, for instance, have a characteristic that once the grid frequency increases, the power feed in of the solar inverters is automatically decreased. In order to stabilize the whole thing, we have reactive power feed in, but that's not enough. You know, it's only a very small portion. And in addition, we offer our SolarBox VR, for instance, which is a grid stabilization, the direct stabilization unit, which adjusts the voltage. Or we have direct reactive power feed in. So we have units, we call them dynamic VAR compensators, which can deliver either capacitive or reactive power. And then we have the storage. So that means battery storage systems and power-to-gas systems. So when you begin, nobody thinks about it. You know, you have only a few kilowatts or megawatts of solar, which you know you don't care. I mean, the grids are multiple gigawatts of power, but when you reach then the gigawatt level, and in Germany we have 40 gigawatts, I think, installed now. I mean, it's the same as conventional power plants, or even more. So you need intelligent power electronics to manage the battery, right? So to charge and discharge the battery, and it's also a rolling forecast, because the system must know in advance how the weather is going to be in the next step, how the consumption is to be in the next step, and there you need a lot of experience in order to, let's say, predict the next step in order to charge or discharge the battery. Then you have to consider the way you discharge the battery, because it's technology dependent. You know, you have to treat lead acid different as lithium ion, for instance, and we provide both systems. A short-term business case is very interesting, is replacing diesel and fossil production with diesel generators by combinations of a photovoltaic plant and a battery storage system, and to build up a hybrid power plant. We call this a hybrid power plant. So normally you have a battery, a solar park, a wind generator. So we have a brand called EcoPax, and then we have off-grid systems for radio base stations or remote villages. You know, up to megawatt, 2 megawatts rated power, where we deliver complete power plants based on solar generation, but as the final backups then diesel, right? AEG is a UPS uninterruptible power supply company, uninterruptible. So that is our really background, and we deliver over decades this kind of systems, a combination of diesel generator plus UPS. That's, you know, now we integrate the solar, and we have done a lot of installations worldwide in more remote regions. That's the one product line, and then we have another product line, which is this grid stabilization, utility scale, linked to utility scale solar. When we do everything right, then the customer is so convinced about our consulting that he buys probably a system from us.
First of all, our new key product, so to speak, is 880 kVA outdoor unit, solar inverter. We launched it here at the show, actually. We have also an indoor unit we are showing here at the show also 880 kVA. And the grid service products I was referring to, we have also voltage regulator here at the show we are showing, and also addressing energy storage solutions in a model. We are offering the outdoor design, the new design, and the traditional indoor design. The indoor approach basically goes along with the historical product offering, where you can combine two units in one concrete station, for example, or metal housing. The outdoor approach is basically driven by the focus on getting costs out of solar systems. But we have to make sure we are driving costs down, and it's not only the inverter itself, it also the balance of system approach and the preparation of the site and so on. So if you visualize that you need to bring 36-ton concrete station to a place, you basically need to prepare the street and so on. So it's an extra effort and investment up front. So with the auto design, which is a much lighter approach, it has just a weight of 1,850 kilograms, it's easier to handle. So even during the installation phase, you are already saving money. This was one of the drivers, and of course within higher power density, in almost the same footprint, you are also saving money. So we are driving costs out of the system. It's really that we want to also make it easier to get the system to different remote sites, and also this is the transportation aspect, but the other aspect is with the auto design, that it is made to withstand in more robust, it's more robust and to withstand in more harsh environments. From the service point of view, there is no difference basically. It's the same design approach. We are not using, for example, different power electronics. So we need to base that on the same design approach. It's basically a configuration question and how to bring all components in this auto enclosure. So we are rolling it out in Germany, and after the rollout in Germany, we're basically adapting the manufacturing processes in the other two countries, South Africa and India. What is challenging right now is rolling out different products into all the different markets with different grid connect requirements. This is quite challenging. We kind of address it in a way that we modularized our software so that we basically can adapt more or less easily the different grid parameters, for example. Another aspect in regard to the US, for example, is that you need to follow different disconnect schemes and requirements. UL requirements are different than, for example, CE requirements here in Europe. And this is what we have design-wise to address. We just recently launched an NPV, modularized design, different power levels. So it's modular in a way so that you use building blocks at 15 kVA, and you can stack these, so to speak, together up to 75, or in a different enclosure to 150 kVA. This is what we just recently launched in the US, specifically designed to the US requirements. It will meet also other standards, so we are also rolling this out to Americas or Asia with a couple of adaptations.